Hi boys and girls, we're going to be doing 16-4. We are almost done with topic 16. Isn't that awesome? And this is the last topic of the year. Awesome, awesome, awesome. Okay, so this topic is about same perimeter, different area, okay? So when you go and you watch the Pearson video, that's the name of the video. Same perimeter, different area. And the name of it is on page 865 in your book, okay? On the same page as your solving chair. You look at the little title at the top of the paper, okay? So before we get started, we're gonna review a couple things about area and perimeter, okay? And today's the first day we talk about area. Okay, so first thing is, perimeter is that distance all the way around. And we started talking about it in 16:1. Perimeter is just the side plus side plus side plus side. All the sides added together equals the area, okay? Now to find it's perimeter, all the sides of the perimeter, sorry. Area equals length times width. Basically, you're multiplying an L, either a backwards or forwards L, whatever. So if I'm looking at a rectangle and I have, for instance, this is 6 centimeters, just pretending, and this is 4 centimeters, you would multiply the two numbers. Now it's not a regular L, it's the top and the side, okay? The top and the side, okay? Whether those numbers are on the bottom, whether they're on the side, you're just multiplying an across side to side and an up and down number. Across and an up and down, okay? All right, so I want to show you a couple of examples of what the topic is talking about, this topic's lesson, okay? All right, we have a couple of different rectangles right here. We have A, B, and C, and I also drew a D because I was trying to play around with the numbers. And all three of these have, four, have the same perimeter. What? They all have the same perimeter of 18 feet around, okay? Here's the deal. As long as this L, and these are rectangles, so the opposites would be equal, 6 plus 6 is 12. 3 plus 3 is 6, so 6 plus 12 is 18. As long as this L is 9, that's half of the perimeter. Two sides is half of the perimeter, okay, for a rectangle. As long as all of them equal 9, they have the same perimeter. 3 plus 6 is 9, 2 plus 7 is 9, 4 plus 5 is 9. All of these have the same perimeter, okay? Even this little guy right here, he is 8 by 1, okay? He also has the same perimeter because 1 plus 8 is 9. But they do not have the same area. If I would try to find the area of these shapes, I would multiply 3 times 6. That is also 18. It's just coincidence that his perimeter and his area are the same, okay? But 2 times 4, this is 14. His perimeter is different from his area, and they are different even though they have the same perimeter. 4 times 5 is 20, and 1 times 8 is 8. Okay, let me show you what the the areas look like. Okay, so this is shape A, B, and C. And don't forget, we're going to put squared now because we would pretend that inside of those little rectangles are little bitty squares that fill it all together so we know how much area they cover, okay? So it's 14 feet squared with a little baby 2, 20 feet squared with a little baby 2. And if we would pretend that we were doing that little letter D again, that would be 1 times 8, and that would equal 8 feet squared, okay? So those are my examples. All right, let's go ahead and look at the solving chair. Okay, it says draw 2 different rectangles with a perimeter of 10 units, okay? That means 2 of the sides have to equal half of this. They have to equal 10, so the L, okay? Because then you would do 5 plus 5 equal 10, okay? All right, so these are the 2 rectangles that I chose, and I actually have 3 examples. I just flipped one of the rectangles, okay? So 2 plus 3 is 5, and if I have 5 plus 5, that would be 10. That would be my perimeter, okay? If you added all the sides all together, it would equal 10. 3 plus 3 is 6. 2 plus 2 is 4. 4 plus 6 is 10, okay? Now the area, if I would multiply it just to say what the area was, it would be 3 times 2 is 6 units squared. And it's units because it told us it was just units, okay? Here's another one. 1 plus 4 is 5. These both have the same perimeter, but they don't have the same area, okay? 3 times 2 is also the same as this one, but it's just a little different because I just took this rectangle and I turned it, okay? But they all three have the same perimeter. Okay, so area says explain why the rectangles have different areas. Well, area has length times width. If you're multiplying different numbers, they're going to have different areas. Lengths and widths are different, so the area is different. So that equals different areas. If I multiply different numbers, I get different answers. Okay? Okay, so this is the Convince Me, and all of this wonderful, lovely stuff right here is on that video that is for 16-4, okay? And basically what it boils down to is these three girls, Beth, Marcia, and Nancy, they have pins for their rabbits, okay? And each rectangle is measuring different lengths and widths, okay? But they all have the same perimeter, because 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6. Okay, 6 plus 6 is 12. So they each have a perimeter of 12 feet. Okay, and then on these little boxes, they found the area. Beth's pin is 5 feet squared. This one's 8 feet squared for Nancy, and Marcia has the greatest. Okay, when we get to a square, they usually are a little bit bigger with the area. Okay, so we have 9 feet squared, okay? All right, find the possible rectangular pins that have a perimeter of 14 feet. Do they have the same area? What can you generalize from this information? I don't even need to solve it, okay? If I do two different shapes that have the perimeter of 14 feet, which they would have to equal 7, for the sides to be to equal 14 feet in a perimeter for their perimeter, okay? And if I did maybe 1 and 6 for this one, are they going to have the same area? No, different side measurement will give different areas because 4 times 3 is not the same as 1 times 6. Okay, the area here would be 12 feet squared, and this one would be 6 feet squared. And I know the numbers got kind of together a little bit, but these are two separate rectangles, okay? All right, let's move on. Now these two are answered because my girls were asking me questions earlier. But it says, in the problem on page 866, what do you notice about the area of the rectangles? Okay, what do you notice about the shape when or the area when it becomes more like a square? I noticed that that area got bigger. Same times same equals greater area. That's why I put GA, greater area. Same number times same number, it gets bigger. When you multiply by a smaller number, like a skinny mini little rectangle like this one times 1, it tends to have a smaller area. Okay, when it was the square shape, it had a larger area. Okay, number 2. Austin is building a rabbit pen with 25 feet of fence. What are some dimensions of the rectangle he should build to have the greatest possible area? Well, if he wants 25 feet, we're doing 5 by 5. Okay. Now, the rest of this page is having you, well, up to number 10, it wants you to draw 2 rectangles for all of these that have the same area but different areas, okay? And they want the one that has the greater area. Now, that's a lot of drawing of rectangles. I just want to do the odd numbers, okay? Let's just do odd numbers. So we're going to do 3, 6, 9, okay? So the first one, we want a 16-foot perimeter for 2 rectangles. Same perimeter, different area. So this is number 3. And I'm going to go ahead and draw my 2 rectangles. And we want 16 feet as our perimeter. Okay? So half of 16 is 8. So my 2 sides on my L have to equal 8 because If these two sides equal 8 and these two sides equal 8, then it's the 16 in the perimeter, because perimeter is all the way around. Okay, so I need it to be 8. So I'm going to do a 4 by 4. Well, that's not a square, but I'm just pretending. And we'll do a 3 and a 5. Okay, so this is my... the directions did tell us to use grid paper. As you notice, I'm not using grid paper because I don't have any. And I don't want you all to go print it or buy it or anything like that. Just solve it on loose leaf paper, okay? All right, now to do the area, we're just gonna multiply the side to side with the up and down number, okay? So this one, 4 times 4, is going to be 16 feet squared. And 5 times 3 is going to be 15 feet squared. And which one's bigger? This one. So we're going to circle him because that's what our directions said. Number 5. 24 inches is going to be our perimeter. So we're going to write that. And draw my rectangles. Okay, 2 different rectangles. Now, half of 24 is 12. So my 2 numbers have to equal 12 on my side to side and my up and down. So I'm going to do 6 and 6. And then I'm going to do 4 and 8. Okay? You could have also done 2 and 12. And then to find out which one's bigger, I'm going to multiply my side to side with my up and down to find the area. Okay, so the area for this one, 6 times 6 is 36. And it's inches squared. Then 4 times 8, which would actually be 2 times 8 plus 2 times 8, which would be 16 plus 16 is 32 if I was using DP, distributive property. Which one's bigger? Oh, the square shape is bigger in both of them. All right. Next one is number 7. We're doing the odd only. Number 7 is the same thing, 2 different rectangles with the given perimeter. Tell the dimensions and the area of each rectangle and circle the one that's greater. So it's the same thing as the first 2 that we did. Okay, so this one has to have a perimeter of 10 inches. That sounds kind of familiar. I think we had one like that earlier. I think I did an example of one of that one. Or no, that was in the solvent share. Okay, so in the solvent share, we had 10 inches was, or 10 units was our perimeter, and we had to find some rectangles that had the same, okay? So we did 3 and 2, remember? And we also did 1 and 4. This one's gonna be easy. And then to find the area, we multiply the side to side with the up and down. This would be 6 inches squared, and this one would be 4 inches squared. And then the top one would be the big one. Ta-da! All right, now I'm going to do number 9. Number 9, if you look in your book, the perimeter is 26 yards. Okay, see 26 yards, okay? And so that is the perimeter. Now I know that half of 26, what plus what is 26? That would be 13. Okay, so the 2 sides have to equal 13. So I'm gonna do 6 and 7 for the top one. And we're going to do, let's do 4 and 9, okay? All right. So then to find the area, we're going to multiply the side to side with the up and down number. And the area is going to equal 42 yards squared. And then do your 9s trick. 9 times 4 equals 36 yards squared. So which one's bigger? It's going to be the top one. I keep making the top ones bigger. Not on purpose. Okay. That's it for the drawing of the rectangles. All right. All right, now we have some colored rectangles. Describe a rectangle with the same perimeter as the one shown. Tell which rectangle has the greater area. Okay, so this is a 4 by 5. Okay. Okay, so the perimeter is going to be 18 because 9 is half of that, okay? So we want the same perimeter. So we want two numbers that equal 9. I think we did one like this. So this is 1 and 8. And it says, tell which rectangle has the greater one. It would be that one, because 1 times 8 is 8, and 4 times 5 is 20. Okay, so this was a 1 times 8 rectangle. Okay, and I'm describing using numbers. Okay, next one, number 12, we have 4 times 3, so that's 7. All right, next rectangle, I'm going to try to make it 7 also. Let's do 5 and 2, and that equals 7. Okay, so the area for this one was 12, and the area for this one was 10. So this one's bigger again. Okay. All right, number 13, 9 plus 5 is 14. So we want to have two numbers on the sides that equal the same. So 14, I'm going to do 7 and 7 because y'all like that one. 7 times 7, roaches on a vine, yucky and stinky, all 49. And this one's 45. And when we get closer to a square, we have the greater area. And this is 49 centimeters squared. Sorry, and I forgot my units for this one too. Oh, sorry. And this one too, I forgot. And so this is 8 inches squared. All right. Now we have a 3 and a 5. I'm going to do another rectangle. So this one's 3 by 5, and this one I'm going to make it the same. So this is 8, and so this has to be 8. So if I make this one square, do you think this one's going to have a greater area? I think so. When we get closer to a square, it seems to have a greater area. 4 times 4 is 16. 5 times 3 is 15. And this one's meters squared. So this one's going to be the greater area, okay? All right, and I'm not quite sure how they want us to describe it. I just drew a rectangle that had the same perimeter as the shown shape, and then I circled the shape that had a larger perimeter. A larger area. And then we are noticing that the closer we get to a square, or if we got a square, and it has the same perimeter, it has the larger area. So square shapes have larger area. Okay? All right. Bye-bye, practice. All right. Common Core assessment, our favorites. All right. So this one, we're just checking off some things about these two shapes right here. Choose all of the statements that are true about the figure at the right. So we're checking off true statements. Well, let's examine them before we even read those statements. So first of all, 3 plus 2 is 5. 4 plus 1 is 5. So I'm thinking they're going to have the same perimeter. Okay, 3 times 2 is 6. 1 times 4 is 4. So the top box, the top rectangle is going to have the larger area. Okay, so let's read what they have. They have the same lengths, side lengths. No, that one's definitely not right. X that off. They have different side lengths. 3, 2, 4, 1. Well, yeah, that one looks good. They have the same perimeter. Yep. We already checked that out because the 3 plus 2 is 5. The 4 plus 1 is 5. And you do 5 plus 5 is 10. 5 plus 5 is 10. They have different areas. 6 and 4. Yes. So 3 true statements and 1 false statement. Okay? And that is all. That is all. So you just have to make sure that your side-to-side number, your length and your width numbers, when you add them together, if they have the same perimeter, they add together to be the same. And then to find the area, you're multiplying your L's, wherever your L might be on your shape. Okay? All right. I'll see you later, boys and girls.